tissue. Okay, here we go. On page 49, at the top of the page, we are finishing up on our margin of error. Okay, everybody, please take a look up at the front Promethean board or follow along in your book on page 49, the top. Politicians, market researchers, and manufacturers, among others, are interested in the true public opinion. Yet, in most cases, surveying the entire population is unreasonable. Come on. Thus, a random sample is used to estimate the true proportion. The margin of error shows the wiggle room on the results of a repeated sample. So we talked about margin of error yesterday, and that was if you won $10 million. Gabe, turn this way. I mean, that's just really odd, okay? All right, so when you have a margin of error, that is the amount that is kind of off, or the wiggle room in your samples, as opposed to the true percentage of the entire population, okay? The smaller your margin of error, the more accurate your information is. The larger your margin of error, obviously, the more issues or problems you can have in your survey. So take a look here at the front. This is actually from last year. Last year was a big campaign year, and we were electing a new governor. Do you know who our governor is right now for the state of Indiana? Who is our governor?
Tom.
Tom? No. Not Tom. It's Mike Braun, right here. So, gubernatorial means governor. I don't know why they don't just say governor. Anyway, back at the time that this poll was taken, Jennifer McCormick, she was the Democratic candidate. And in the survey that this poll did, she had a 39%. 39% of the population would have elected her as the next governor. Mike Braun was 42. Donald Rainwater was the independent, and he had 9% at the time. We also had 13.3% who said they were undecided. Okay? People, put the phones away. All right, so it says, notice the margin of error on this poll. Here's your margin of error up here in the upper right-hand corner. Plus or minus 3%. Okay? Now, if you add these together, what do you get when you add 39, 42, 9, and 13.3? What do you get when you add those up? You are correct, sir. You should maybe use a calculator. What do we get when we add those up? $90 plus you have the 13.3%, which are undecided. So that's kind of over 100%. Our margin of error is plus or minus 3%. So if Jennifer McCormick, the Democratic candidate, if we added 3% to her amount, that would give us what? 42. So her upper limit, according to this plus or minus 3%, would be 42. What would be her lower limit? That would be minus 3%, which gives her 36. Okay. If we go to Mike Braun, 42% plus 3 would be 45%. If we give to the minus 3, that would be 39%. That's okay. It's all right. And Donald Rainwater, 9%, plus 3 would give 12%, minus 3 would give 6%. So if I chose, take a look at this. If I chose the upper and said plus 3% for Jennifer McCormick at 42 and took the minus 3 for Mike Braun, you actually have a very different poll. Okay? So that margin of error says we're not absolutely sure, okay, because there's plus or minus 3 percentage points of error, but the more samples we could take, we could get closer to the actual results of what the entire population would be, okay? So just know that the amount of percentage points can make a big deal when you have a very close election. All right? Even though somebody might be leading, if the percentage points are pretty large, maybe it's not a very good poll. All right. So now turn to page 50. Page 50. Now, this, in our books, in our regular books, it talks about M&Ms, but some people are allergic to peanuts, so we no longer use the M&Ms. So we're using Skittles, okay? And this is kind of different. This says, Skittles, can I look at your book here, please? Thank you. Skittles that are owned by Mars Incorporated used to publish color distribution of candy in production. They no longer publish this data. However, we can use sampling techniques to see if the last release of the data in 2008 is still valid. So this is from your books. Back in 2008, they said that 15% of all of their candies were yellow, 20% were green, 15% were red, 25% were orange, and 25% were purple. Okay? So I need you to calculate the distribution of your sample of Skittles. Okay? How are you getting your Skittles? Well, by way of, and this is how I did it. If you want to know how I put these Skittles in, I did not count them individually. So there are not the same number of Skittles in each one. All I did was kind of eyeball it. I stuck the cup in the bag and said, shook it a little bit, said, oh, that looks like about 2/3. Okay? So you need to find your percentage of each color. And then we're going to actually show for the color purple. But I want you to find the percentage of each color in addition to the purple. So how can you find a percentage? What are you going to need to do? What do you need to do in order to calculate a percentage? Ladies and gentlemen, what are you going to need to do in order to calculate a percentage, let's say, of your yellow Skittles in your cup? Count what? What are you going to have to do to calculate the percentage of yellow Skittles in your cup? Okay. Yes, you'll have to count all of the yellows. And you will have to divide it by the total number of all the Skittles. Now, do not eat them until you have calculated all of your percentages. Okay? Do not eat them until you have calculated all of your percentages.
Bro, y'all two just been looking at who you were there.
So none of these Skittles have been touched by hand, but yes, the little Dixie cup, I have touched the outside of the Dixie cup. Okay, I know, right? So you need to, on page 50, calculate the percentages of all of the colors of the Skittles. Did everybody get a container of Skittles? Once you have your percentages calculated, then you can write them down.
Wait, so you just
and
want
you can eat them.
you just want us to count or just separate by color? Or
Well,
how do
you
want-
need to find the percentage of yellows, greens, purples, reds, and oranges. So yes, I would separate them by color. Sean, let's go.
Can I go to the bathroom?
Yeah.
the fur?
Now, if you are a person that does not care for Skittles, perhaps there is someone near you who
Hey, are you gonna eat?
might take them even if you have already touched them. But if you don't, you're fine to throw them away also.
Yes. 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 Are you gonna eat them? Damn.
Oh wait.
Damn. I don't know if the I should do the 5-second rule. Should I do the 5-second rule?
I'm sorry? You're gonna put the number of each color over your total. Oh. No, it would be 10 divided by, right, and then you move your decimal to 2 places.
Wait. No.
Hey. Huh? Huh?
No, you'll get the
Yo no sé qué es
decimal
eso.
on your calculator and then
Are
put
you
it
gonna eat 'em?
into a percent.
Huh? Can I have?
What's the question?
Where are we writing them?
Just on page
Devinus.
50, page
Devinus.
50, yes.
Pass me my calculator.
So if you have like 20 yellows, 20 over 49, yeah.
So I already separate them. So what do I have to do now?
Okay, so how many yellows do you have?
1, 2, 3, 4, 5,
And you
6.
put that
7.
divided by the total number that you have.
Oh, the number of Skittles I have. Hijo, the number you get them now.
What the?
Hey,
That's a blue.
hey, you can still get them.
Okay, so these
Devinus.
are all the Skittles you have.
Devinus.
How many do you have total?
Devinus. Devinus. Are you gonna eat them?
So you would put 9 over 46, and that gives you, and you would put 5 over 46, and each of those numbers over 46.
40.
And when you do that on your calculator, it will give you a decimal, and then that is your percentage.
Oh, so
6, 7,
Okay?
was that like
7,
50%?
So that is the last data that Mars gave us, saying we have 15% yellows in each of our bags.
Oh, so this is the.
That was the 2008.
Okay.
So we are seeing if that is still accurate.
Alright.
Our what?
I get it.
You could round to the nearest percent, or you could put 0.1 or 0.3, that's up to you. So now, when you move it 2 places to the right, it's not 3.2%, it is 23. That's 23.2. That to the left is your whole number of the percent. Does that make sense? So this is 13.9%, 25.5%. Okay?
I don't know how to do that.
Oh, you don't mean like your hands.
I know how to
We wait until everybody comes in. Okay, not everybody needs to come over. Everybody should be different. Places to the right, everybody in. You can go, since it's 0.195, you could say 19.5, or you could round it up to 20. So hang on to this, and then is this distribution, do you feel this is still accurate? And then I'm going to get data from our class on just purple. Yes.
Hey,
You said you should try.
anyone gonna eat their scooters?
You had 9. Wow. That is
That's a lot of people are trying to.
okay.
I
So
can't
these are all the
do this.
same.
That's fine.
Well, I would say this is like 18.7%. Or you could say 0.7 rounded to 19. Yeah, 19. And this one, that's 25.
What I do, I'm trying to recruit.
Do you have your percentages calculated?
Don't do that. Do not do
Yeah, it's
that.
not the same one.
I will
kill
do that. Do not do
Did you get percentages for all?
that. Yeah, she really trying to. Maybe she's not even.
Again?
Okay, I got. So I got your thing all last year.
No, I got there, so I cleaned my.
But how is that very good?
Why do you go
This is the story what happened. I was running the 200 break.
But it's not part of your
My
day
ex
at
was
all?
there. My ex was there. So my ex was there, right? It's the first time for seeing me was 2, right? So I'll tell you that's that track. So I was telling all my friends, they said,
So
oh,
I
that's
say
it.
percent,
I
I say
say,
11%.
let me win this race. Yes, because they were winning all the races. I was like, let me win this race. They said, okay, what's your best? Look.
Uh-huh.
Oh, I don't know. I just counted how many.
Well,
I only got 2.
this was
So,
for your yellows,
we on the
right?
race.
So you got 20%,
I'm the first
you
place
had
to go half,
15.
right?
Is that still
The
the
whole
same?
first half. And then
There you go.
they get it first.
Keep that.
And
All
I was
right.
last place, and they all just.
Does everybody have their percentages?
No.
That's a dream.
Does everyone have their percentages?
During the race.
During the race.
During the race, they also running back.
They all started running back in the air and
During
during
the track.
during the track.
No, they did not. Oh, maybe
You wanna I hit that. I hit that.
How would they?
Okay, so then you take the number of yellow
Whoever the official.
divided by the
I think
total
they're-
number.
They already passed mine.
Okay, wait, decimal.
Okay, I forget what happened to the race. I'm like,
Places to the right, like your percent.
awesome.
So 15 out of 52.
Yeah, that's what I mean.
You're at 2.008, is that right? 0.2008?
It's
Oh,
just regular.
0.8. So that would be, you can either say 28.8%, or you could round.
No, that's fine.
How was that bad?
No, it's not bad.
Alright, so let's check some of these percents and see. You got it. Alright.
I counted how many I had.
Okay, so, oh, we are going to use Kodak